All right, so now that we know what oxidation numbers are, it's very easy to write chemical formulas, and I mean that very sincerely. The first type of formulas we're going to write in this video and in this lesson are just regular old ionic compounds, okay? So this first section is the easiest formulas, are the easiest formulas that you'll write. Here we go. So to review from just a second ago, or the last video if you're at home, we now know the oxidation numbers of the 8 perfect tall groups, right? Here they are. Group 1 plus 1. Group 2 plus 2. Plus 3. Carbon special because it's at 4 and we don't know which way it's going to go, right? So plus or minus 4. Negative 3, negative 2, negative 1, and nothing, right? So if you have a periodic table, then you should write on it, or you can make yourself like a little loose sketch of the table on the edge of your paper. I have students do that all the time. And they just write plus 1, plus 2, plus 3, plus or minus 4, negative 3, negative 2, negative 1, okay? Then I'll go ahead and just like put H, L, I, B, E, B, C, N, O, F. I don't know what these letters stand for. I just like to write them down. That is a joke if you're at home. Okay, so here's all that you do. Atoms connect with each other until they're neutral, right? So let's take a look at what happens. Let's bond some lithium to some oxygen. All right? Here's what happens. Just watch. Here's a lithium atom. And now over here in green, I'm going to put an oxygen atom. Okay? So just watch. The oxygen atom is far more electronegative than the lithium atom. So it's going to take that electron. Boop. Right? This lithium will shrink. Now it becomes lithium plus 1. So that electron was taken to there. Well, the outer electron was taken to there, right? I like the way that picture looks a little bit better. Now, does this oxygen have all the electrons it wants? It doesn't. It's got 1, 2, 3, 4, 5, 6, 7. So something you need to keep in mind is when atoms are bonding, there are always trillions and trillions of them available. So here's another lithium atom hanging out, and oxygen takes one from it too. Now, everybody's happy. Does that make sense? This guy's lost his complete outer shell, right? This guy's lost his complete outer shell. And this guy's filled his outer shell up. How many lithiums did it take? It took 2 lithiums, so we will write L, I, and a little 2 right here. That's called a subscript. And then how many oxygens are here? 1. That's it. That's the formula for lithium oxide, Li2O. That's pretty simple, okay? Now, I'm going to show you the quickest and easiest way to do it. Ready? Here's our table. I say, hey, what is the formula for lithium oxide? And you say, okay, lithium is in plus 1. So I'm going to write Li plus 1. And then you say oxygen. it's in the -2 group. All right. O, -2. Okay? Then you just take those two numbers that you wrote down and you crisscross them. Li2O. Done. Never going to be wrong. See how easy that was? It's very easy to write a chemical formula. As long as we're just doing binary, ionic formulas. This is what we're doing right now. Binary means just two different atoms. Okay? Now check this out. Let's write another one. Let's write another one. Because I think you can see this is easy. How about I ask you to write a formula for beryllium sulfide. Okay? I'm putting this "ide" on here saying that these two are bonded. Does that make sense? I'm not writing beryllium sulfur. I'm writing beryllium sulfide. And if there's a glare at home, beryllium sulfide. Okay? So, here is beryllium. What is its oxidation number? So you can just write Be +2. And then sulfur, where is it? Who's it right beneath? Sulfur's right here, so it's in the -2 group. So sulfur is -2. All right? We're going to take these two numbers and cross them. No, we're not. We're not going to cross them down. You know why? This is already equal to 0. What's +2 -2? 0. So the formula for this is just BES. Just like in math, you wouldn't write these down twice. Let me show you why. Let me show you why you just write BES. Okay? Ready? Here's a beryllium. Make sure I'm on screen here. Here's a beryllium atom. It's got 2 valence electrons, right? This is beryllium. And then over here is sulfur. It's 2, 1, 2, 3, 4, 5, 6, 7, 8, 8. 1, 2, 3, 4, 5, 6. 2, 8, and 6. Here's sulfur. Guess what? That electron goes there. That one goes there. And we're done. You don't need 2 berylliums and 2 sulfurs. You just need one of each. They work together perfectly. Does that make sense? Didn't this sulfur want 2 more electrons? And didn't this beryllium have 2 to lose? So you're done. So if the numbers are the same, then they just cancel out. I'll repeat that for people at home. If the numbers are the same, then they just cancel out. And this is why. Doesn't that make sense? Okay. So let's write another one. All right. How about we write a formula for potassium nitride. Potassium nitride. Okay. Potassium is +1 because it's in this group right here that says +1, right? And nitrogen, what's it? What's its oxidation number, Sullivan? -3. Nitrogen is -3. Very simply, we've looked up our numbers. We can just do this. Ready? Yank, yank, K3N. Does that make sense to everybody? Right? That's how simple it is. And why is it K3N? Let's watch. We know that it's K3N. I'm just going to write that here. All right, here's a potassium atom. 2, 8, 8, and 1, right? That's potassium. Here is nitrogen. 2 and 5. This electron will be taken, scoop, Now, nitrogen needs 2 more electrons, doesn't it? There are always trillions and trillions of atoms available. So guess what? Needed another potassium atom. Now, is that nitrogen happy yet? Let's go. 1, 2, 3, 4, 5, 6, 7. Nope. We need another potassium atom. So it actually takes 3 potassium atoms to hook up with 1 nitrogen, K3N, right? You don't have to draw this stuff every time. All you have to do is what we've been doing, which is look at your table, say potassium's in +1, potassium is +1. Nitrogen is in -3, nitrogen is in -3. Crisscross K3N. Done. That's how you write binary formulas for simple ionic compounds.